AP Physics 1, 2017 free response. Question number 2. A student wants to determine the coefficient of static friction between a long, flat wood board and a small wood block. A. Describe an experiment for determining the coefficient of static friction between the wood board and the wood block. Assume equipment usually found in a school physics laboratory is available. I. Draw a diagram of the experimental setup of the board and block. In your diagram, indicate each quantity that would be measured and draw or state what equipment would be used to measure each quantity. II. Describe the overall procedure to be used, including any steps necessary to reduce experimental uncertainty. Give enough detail so that another student could replicate the experiment. So we want to determine the coefficient of static friction. Now there are many ways to do this, but the first idea that comes to mind would be using a ramp. So here would be the wood block. This is the wood board and the wood block on it. So essentially what this experiment would be doing is that we would keep increasing the angle until the block just starts to slide. And that would be the point where the component of gravity equals our frictional force. So at that moment, we can then use our equations to solve for the coefficient of friction. So the main component here would be theta. So we have Fg sine theta, that's the component of gravity, minus the force of friction. And we want them to be equal to each other so that the block just starts to slide. So we can expand to say mg sine theta minus mu mg cosine theta is equal to 0. And these are the values for each. Force of gravity is mg, so mg sine theta. And the force of friction is equal to mu times the normal force. And normal force on an incline is equal to mg cosine theta. So we can divide by mass on both sides to say g sine theta minus mu g cosine theta is equal to 0. So from this equation, we see that we only need to find theta to determine mu, as g is a constant at 9.8. So we can need the angle between the board and horizontal, which can be measured using a protractor. So for part I, this is our diagram of our setup. And in our diagram, the quantity that would need to be measured is the angle theta. And the equipment used to measure it would be the protractor. Now for part I, we need to now describe the experiment. So this is our image from before, and now I would go more in depth. So we place the board on the level table with a block on the board. Then we slowly lift one edge of the board with a protractor measuring the angle between the board and table as we lift the board. We keep lifting the board just until the block starts to slide. We record the angle at which this occurs. Repeat this process multiple times and average the angle values at the end. Then test all the previous steps at multiple locations of the board to reduce experimental uncertainty. So this would be a process which includes experimental uncertainty for determining the coefficient of friction. Now B, determine an equation for the coefficient of static friction in terms of quantities measured in the procedure from part A. So this was our diagram, and we know that in our diagram, we want the component force of gravity to just equal our static friction. This is our equation from earlier. Thus, we expanded to say g sine theta minus mu g cosine theta is equal to 0. Now we want to solve for theta. We can factor out the g to say g times sine theta minus mu cosine theta is equal to 0. We can divide g on both sides to say sine theta minus mu cosine theta is equal to 0. Thus, we can add mu cosine theta to the other side, and then divide by cosine theta to solve for mu. So mu would be sine theta over cosine theta, and sine theta over cosine theta is the same as tangent theta. So in the end, coefficient for static friction would simply equal the tangent of the angle. Now for part C. A physics class consisting of 6 lab groups wants to test the hypothesis that the coefficient of static friction between the board and the block equals the coefficient of kinetic friction between the board and the block. Each group determines the coefficients of kinetic and static friction between the board and the block. The group's results are shown below, with the class averages indicated in the bottom row. C. Based on these data, which conclusions should the students make about the hypothesis that the coefficients of static and kinetic friction are equal? let's compare the data values. For lab 1, we see that kinetic friction is less than static. That is also the case in lab 2, lab 3, and lab 4. But here in group number 5, we see that the coefficient of static friction is much larger than normal. And we see that static friction is also much smaller than normal. So in this case, we see that kinetic friction is larger than static friction. Now for the last group, we see that it's back to normal and kinetic friction is less than static friction. So through these data values, we see that group number 5 is an outlier. The coefficient of kinetic friction at 0.74 is way larger than the other groups of roughly around 0.45. We also see that for group 5, their coefficient of static friction is much smaller than what the other groups observed. Thus, we can reason that no, the static and kinetic frictions are not equal. Lab group 5 is an outlier compared to the rest of the data, which clearly shows that kinetic coefficient is less than static coefficient. And we saw that earlier when we compared them. So if we ignore the outlier, we further see that the coefficient of friction is roughly 0.45, while the coefficient of static friction is roughly 0.54. Thus, the two are not equal. So we can say that the static and kinetic coefficients are not equal. Now, when we look at data, scientists must observe the data individually and not just average at times. So when we look at the data, we have to ignore these outliers, which would throw off the rest of the data. That's why we can ignore group 5 and say that they are indeed not equal. Part D. A metal disc is glued to the top of a wood block. The mass of the block disc system is twice the mass of the original block. Does the coefficient of static friction between the bottom of the block and the board increase, decrease, or remain the same when the disc is added to the block? This situation compares when the mass is doubled. We earlier said that the coefficient of friction is simply equal to the tangent of theta. So from this equation, we see that even if mass is changed, that means the coefficient of friction won't change at all. The coefficient of friction only depends on the angle between the board and the surface. Thus, from our equation found in part B, we see that the mass has no effect on the coefficient of static friction. Only the angle does. Thus, increasing mass won't affect the coefficient of static friction. So we can check off remain the same. And this concludes the second question on the 2017 AP Physics 1 full response.